All right, welcome back to the channel. Today I'm going to explain to you how domain fronting works, which is where you see one domain name listed like on a link, but then you click it and it takes you to a separate domain. And a lot of times this is used to spread malware. I talked about this in the malvertising campaign, or how malvertising can give you viruses in reference to like how they will run an ad. It looks like you're clicking on one link, but it actually goes to a virus link. I figured this would be a good video to make to explain how this stuff works, because I'm sure some people were wondering like, okay, well, how in the hell can this actually work where you can get a virus from clicking on one domain, but you actually end up getting sent to a different domain. So let's go ahead and jump right into it. So the example that I'm going to give here, so I'm going to use this throughout this example that I'm going to talk about here, is how you can have something like, let's say you click on what you believe is gooddomain.com, but then you go to malwaredomain.com. So that would be an example of like, so in the malvertising campaign video that I was talking about, it would be something like where you click on, let's say, adobereader.com, but then you go to wannacry.com or something like that. Now, there's a few reasons that this kind of stuff is used. One of the uses of it is to be able to avoid things like censorship and to also help protect whistleblowers, which can come into play like where let's say there's a government program that's watching, like a big government firewall that's watching all the internet traffic of its users, and it looks like a person's clicking on one domain, but then it clicks on another. It's really not the greatest example, and there's other better ways to get around that, like using things like V2Ray or Shadow Socks, or maybe a VPN, except that can be risky, or Tor if the government's not blocking it. But it is a use case nonetheless, although not really a common one anymore, because a lot of CDNs, content distribution networks, are starting to crack down on it. But then malware can use it as well. And the C2 that I have listed here means command and control. So that would be like where, let's say you get a virus on your computer and the virus communicates with a command and control server or C2 server, and there's communications going back and forth as to like data that it's exfiltrating out of there, or incoming commands, so like a hacker can tell the malware what to do on your system. So let's go ahead and jump right into how this stuff works. So you have your basics. So the way domain fronting works is obviously you have your DNS that resolves to an IP address. So I've mentioned before, DNS is like a phone book for the internet. Now this can be a problem because obviously malware or malicious DNS can be hidden in the DNS traffic. And then you have HTTPS, which works in hand with TLS, which is transport layer security, which helps do things like encrypt traffic going to and from a website. And then you have the TLS handshake, which is where we start coming into play with how domain fronting works. Now, just to give you a very brief explanation of how this works, how a three-way TLS handshake works, is you have the client computer sending the synchronized packet to the server. The server sends a synchronized acknowledge packet back to the client, and then the client sends the acknowledge packet, and you then have a connection established between the client and the server. And in the previous video, basically like the most simple way of explaining this is the client, this is the server. It works like this would be like saying, hey, are you there? Then the server responds back, yes, I'm here. What do you want? And then the client responds and says, okay, here's what we're going to talk about. So this is where domain fronting starts to come into play. So in domain fronting, you have something called server name indication, which is used as part of TLS. And so you have client to server here, which what I mean when I say this is you can have multiple websites on one IP address. And I would explain IP address in a different video because it would take a really long time to explain how the whole IP system works. But to keep it simple, there's IPv4 addresses. So you have basically anything from 0.0.0.0 to 255. So on and so forth. Now, the issue with that is that IPv4 addresses are becoming extremely overloaded, and there's this whole stuff with IPv6, which again, would be a whole separate video. But basically, the reason that you would have things like this, where this is even possible, is because you have to have multiple sites resolved to one IP address, because there's not enough IP addresses to go around for everyone and everything that's on the internet. That's why you'll see like multiple sites use the same IP address, or like if you've ever noticed, like when you use a mobile carrier and you use like a data plan or something like that, you can be assigned the same IP address. Or how if you're using a VPN, for example, your VPN connections, you could have like, let's say 10,000 people use a VPN. They've got 10 servers and you average it out like to 1,000 people use the same IP address. Like if you've ever noticed, if you've ran a VPN before, is sometimes they'll go to websites and they'll say suspicious activity has been logged by this IP address. That's what's happening because you have 1,000 different people. Obviously, there's some people that have suspicious activity using that IP address. So that's what's going on with all that. Now, when that TLS handshake is resolved, you have something called an HTTP header being sent that is encrypted through HTTPS or through the TLS. And so here is what that looks like. So in your server name indication, this is something, so like a firewall would be able to see this. So your firewall sees, okay, the link is trying to go to gooddomain.com, but then once that encrypted connection is established, then this HTTP header gets sent over, and there's a host section that specifies, okay, we're not actually going to go to gooddomain.com, we're going to go to malwaredomain.com. And so let me give you an example of what a header looks like in this case. So let me walk you through what you're seeing here. So this is an example of an HTTP header. So this up here, up at the top, this could be some additional commands being received, like, okay, we want to run some more commands or something to that effect. Here's the host field of the HTTP header. So even though SNI might indicate, server name indication might indicate that you're supposed to go to a good domain, the host field in this header could say, okay, we're actually going to send them to malwaredomain.com. And then this other stuff that you see in here, so user agent. So this would be like just a standard user agent string. This is things that like malware can use to blend in. Then this is just some other miscellaneous stuff. This is pretty self-explanatory, like accept encoding. This would be like, okay, well, we're going to use gzip or one of these other encryption or compression methods to help make the website load faster. You've got your cookie session here. You have your connection, keep alive. And then this x-c2-data could, for example, be something that would refer to like a custom header where there could be further instructions being executed for the malicious domain. And so let me give you another example of headers just to help make this, just to help give you a further visual of how this stuff works. And so this is a pretty common thing and I can make a whole video, so I'm just gonna give you like a very brief rundown of how this stuff works. Because like I said, I could literally make a whole video on how HTTP headers work. So here's an example of an HTTP header, just so you can get an idea of how much information is going through headers. Now you'll see some different stuff in this header, like the authentication method here, which is super important if you're gonna set up like a business email, for example. And so this is saying, okay, we've received an email coming from this server. So let's say the example here is ken@ken.com. This is a permitted sender. You'll see IP addresses being sent through here. And I'll make a video explaining this in more detail, but one of the things that could happen here now, pretty much all the clients should have this patched out at this point, like email clients. At one point, you could actually end up seeing the person's real IP address through this. It's a security problem that should no longer exist. And you'll see things like user agent. So this would say, okay, this person sent the email from Outlook or Thunderbird. Here's where it's going to. And so for those of you that are working in an organization, you've probably seen like a report spam button. Like when you get an email that looks odd show up in your inbox, there will be a button that says send this email or report this email as phishing or something like that. And that goes over to the IT team where we look at stuff like this and we're like, okay, what's going on with this email? And we'll take a look at things like the SPF records and DMARC records and all of that to see what's actually going on with the email and find out who's sending this stuff. So I'm not going to get super in the weeds on headers, especially in regards to emails, but that way it kind of gives you an idea of just how much information you can cram into a header and that you as the user will never see the header, but there's a lot of stuff that can be concealed in there that can be a problem for you. And so you're probably wondering, okay, well, how in the hell can I protect myself against this stuff? Now, the thing is, let's say you end up clicking on a link that goes to a malicious domain. You think it's a good domain, but you end up being a victim of a domain fronting attack. This is where having things like a good antivirus is really important so you can block it. And if you have like DNS filtering and it tries to forward to that domain, hopefully your DNS filter can catch that and block it before it even has a chance to get to your computer. So in that case, for example, running something like Claude 9, where they just block the traffic from being able to go through. What's really happening here at this point is that a lot of this fronted domain stuff is getting blocked at this point. And a lot of these CDN, so CDN is the content distribution network. So that's places like Cloudflare. What they're doing at this point is a lot of them are blocking domain fronting from being able to work. And when you do see it allowed, what they should be doing is checking and making sure that the host field and the SNI both match so that it's going to the same domain. And if there's a mismatch, it should be getting blocked, hopefully. Now, you as the user don't really need to worry about this all that much because, like I said, a lot of this stuff is being clamped down on at this point. And it, like I said, if you ever should end up clicking on a malware ad that looks legitimate, but it actually goes to malware or something like that, this is where things like antivirus become really important so that when you get directed to that domain, that you don't get hit by a drive-by download that happens in the background, like a one-by-one GIF loads, and then you end up getting infected with malware, like fileless malware. You're not even aware of it. Like, this is just bad stuff all around. Like I said, you as the home user don't really need to worry about this stuff all that much. I know a lot of these cybersecurity videos kind of give this insane impression that things are really bad. And I mean, you can be hacked in a lot of different ways. But like I said, just having a good antivirus, a firewall, using some common sense will go a pretty long way to keeping you from having to deal with this kind of garbage. Anyway, that's going to wrap the video up. I appreciate you sticking around for the 2 people that are still probably watching this because some of these videos get really detailed. I tried to keep this one short instead of going on for like 40 minutes, and it looks like I was able to reach that objective, so that's good. Anyway, if you want to see anything in particular, just go ahead and drop a link or drop a comment down below. Let me know. Got lots of good stuff coming, and so hope to keep seeing you coming around. Anyway, that's going to wrap the video up, and I hope you have a good day, and I will see you on Monday.